So I'm Patrick McDermott, and this is my Unit 4 mid-unit assignment. So the regular motion of the Earth about the Sun causes the daily change in high temperature at any location on the Earth. The chart and graph show the average daily high temperature in degrees Celsius for each month in Yellowknife, compiled for several years. Determine the trigonometric equation that models this information. Let y be the temperature in degrees Celsius and x be the numerical value of the month. So as you can see right here, I have the original function at the top, and to determine the amplitude, I did max minus min with values that I had from the chart on the right, 24 minus 21 minus negative 24, which gives you that, and then 22.5. I determined C by doing the same thing with different values, but max plus min, giving me 1.5 as my C value. To determine the K value, I just did 2 pi over the period, which would be 12, giving me pi over 6, and the D value is 1. And right here is my function. Question 2 asks, a Ferris wheel has a diameter of 10 meters and takes 24 seconds to make one revolution. The lowest point on the wheel is 1 meter above the ground. Sketch a graph to show the rider's height above. Sketch a graph to show how a rider's height above the ground varies with time as the Ferris wheel makes a rotation. Assume the person starts the ride at the lowest point on the wheel. So here is my graph, and you have it starting out here at the lowest point and going up, reaching its highest point, and then going back down. And on the sides you can see it's labeled height in meters and time in seconds. 1 second. 2b asks, write a trigonometric equation that describes the graph. And that is what I, 1 second. That is what I have right here. So I start with the original function at the top, and I find the A value by doing the same thing, max minus min, which gives me an A value of 5. I do the same thing previously that I did to find the K value with 2 pi over the period, with the period being 24. So my K value is pi over 12. I determine my C value by doing max plus min divided by 2, which is 11 plus 1 divided by 2, giving me 6. There is no D value, so given that there is a reflection in the x-axis, you will add a negative to give you the equation of y equals negative 5 cos pi over 12 times x plus 6. 2c asks, check the accuracy of the equation by using t equals 12 seconds. Explain why this provides a check of the accuracy of the equation. What are 2 more values that would provide a good check? So I did that. I plugged 12 into my equation. 1 second. Right here, as you can see, giving me negative 5 cos bracket pi times 12, pi divided by 12 times 12 plus 6. And you can see by going down the equation, at the end, the function gives me 11 as my value. So using 12 seconds provides us with a good check for the accuracy because it shows how at 12 seconds, the rider's height is at its maximum, being 11 meters. This is a good check because it provides the same answer as the previous graph, proving our solution correct. 2 other good points to use this check would be 0 and 24, as they are both at the rider's lowest point. Question 3 asks, the height of the tide in the Bay of Fundy relative to a pier varies from a low of 4.5 meters at 2:08 to a high of 17.3 meters at 8 minutes 21 seconds, measured with a 24-hour clock. Assume that the height in h of the tide can be modeled as a cosine function of the time of day, t, and then determine the equation in the form height at time equals a cos bracket k times t minus d plus c. So that is what I have right here, the original equation on top, and I determine the A value as previously done, give me 6.4. I find the K value, and I find the period, which is 12.44, and then I find the K value, which is pi over 6.22 by just using the previously found period. I find the C value, doing max plus min, which gives me 10.9, and the D value, which is 2.13, which you can find by converting 2.08 into a number, a physical number, which is 2.13, and converting 8.21 the other time into 8.35. So the equation would be negative 6.4 cos times pi over 6.22 multiplied by t minus 2.13 plus 10.9. 3C asks, determine the height of the tide relative to the pier at 11:30. Give your answer to the nearest 0.1 meters. So as you can see, I first converted 11:30 into a time. So you do 30 divided by 60, which was the same to get these two numbers, giving me 0.5, and then you get 11.5 as the 0.5 replaces the 30 in the 11. So 11:30 we're going to turn into 11.5, and then you substitute that into your equation, which gives you 10.8 meters, which would be the answer. 3D asks, a boat needs a depth of at least 12 meters to dock at the pier. Use a graphical approach to determine when the boat is able to dock and when it must leave. Here I have part D. On the side, I have my height in meters, and on the bottom, I have time. You see I start out at 2.13 and 4.5 on my graph, and it reaches this point in the middle at 8.21 and 17.3, and finishes at 14.7 and 4.5. You can see how I got those numbers there, with there being a 6.22 meter difference in between the three numbers, and therefore that gives me the answer that the boat will be able to dock roughly between 6 and 11. Thank you.